So we're looking at similarity of polygons. So congruence has to do with two structures to be of same size and shape. Both size and shape has to be same. But similarity is two objects or two things or two figures are said to be similar if their shape is same but the size is not. Okay, it might be equal or it might not be equal. It doesn't matter. Best example is your toy models, right? Like say you have a Sukhoi or some say you have a space shuttle wala setup, or if not, what else? What else can I tell? Lego set depicting some particular character. If not, Hulk. You have different characters, superheroes and their structures. Right? They look the same to whatever they show either on the TV or physically it is like space shuttle. Physically, it's too big, but what model you have, it looks the same, right? So those objects are said to be similar. The rocket, space rocket, and the model depicting that, those are said to be similar. So why? They look the same, but the size can be anything. Size does not matter. So they have to look the same. Basically, that's the basic idea of similarity. How is it used and all? It is very useful. The point is, first the definition, right? So similarity of polygons. Now we are going to the technical aspect of how can we tell two polygons are similar. That definition you have to learn. So two polygons are said to be similar if their angles are corresponding angles are same and the corresponding side ratios are equal. So we have to pick two polygons with the same number of sides. Right? If you take a triangle, you have to compare with another triangle. If you take a pentagon, then compare with pentagon, hexagon, compare with hexagon, octagon, whatever it is, right? Circle, whatever the structure it is, square or rectangle, whatever it is, you have to compare with their respective, number of sides has to be same. So it's like comes from the same family, I guess. Right? Let me give an example. So let me draw a triangle. On that, I am okay. It's my triangle, and now we have okay, let me do a better job. Right, these two structures are said to be similar. Why? Because they look the same. If you zoom in and out, they look the same. Just that the size is different. So if I take ABC to be of size 10 centimeter and say this is around 16 centimeter and this is around 14 centimeter, this if it's 5, this will be 7 and this will be 8. Now, if you okay, first thing is let's understand corresponding angles. What does it mean? Angle B is corresponding to this particular angle. Angle A is corresponding to this, and angle C is corresponding to this. Okay. Why? Because they are related through similarity, and that's why they're being told as corresponding. Then AB is corresponding to this side of length 5. AC is corresponding to this side of length, and BC is corresponding to this side of length. So these are corresponding sides. Okay. So now say we have a hexagon, right? So I need to compare it with an hexagon. That's the rule. So what drawing I mean, both are hexagons. So the two polygons of same number of sides. So both are hexagons. The corresponding angles if they are equal. So basically these are the corresponding angles. Whatever I'm marking, these two are corresponding to each other. These two are corresponding to each other because they are equal. So corresponding angles are equal. Yes, they are. Corresponding size sides are of the same ratio. Okay. Next is we'll look into this because angle is quite simple. It measure and both are same. But what is this corresponding side are in the same ratio or proportion? See, if I take 10 by 5, the ratio I'll get 2 by 1. If I take 14 by 7, I'll get 2 by 1. If I take 16 by 8, I'll get 2 by 1 as the ratios. So look at the ratios, they're same, is it not? So corresponding sides are in the same ratio. This is what they're talking about. If I know which two sides are corresponding, and if I take their ratios, all of these ratios will be equal to each other, given the figure is a similar triangle. Or if we can tell that if the side ratios are same, then their figures are similar. So there are ways of proving that two triangles are similar. That's what the chapter is about. And using that fact and proving few more things. Okay. So this is the basic idea of similarity. So we'll be doing practicals. We'll talk about the usage and things and the numericals.